Welcome to our deep dive today. We're going to be exploring some research from Microsoft Research Asia.
Okay.
It's called rStar-Math. Small LLMs can master math reasoning with self-evolved deep thinking.
Sounds interesting.
Yeah, it's really cool. It's basically about how this new technique, they're calling it rStar-Math, can help smaller AI models, solve complex math problems, even to the point where they're surpassing the larger models.
Right.
And one thing I think is really cool about this is this research. It's not just about AI.
Right.
It actually gives us some insights into how we as humans learn best.
I see. Okay.
So, we all know that large language models, LLMs as we call them, they're really good at a lot of things,
Right.
but they often make mistakes, especially with more complex tasks like advanced math.
Yeah, I've noticed that. They kind of seem to rush to an answer
Yeah.
without really understanding the problem.
Yeah, and that makes me think, like, is that sort of like our own System 1 thinking?
Yeah.
You know what I mean? The quick, intuitive, but not always reliable kind of thinking.
Yeah, exactly. That makes sense.
Like if you're choosing a snack, right? That's a System 1 decision. But if you're planning a trip,
Yeah, right. Yeah.
a big, complicated trip, that's when you need to engage your System 2 thinking, that slower, more deliberate, careful process.
And it seems like that's what this research is all about. They're trying to get AI to use that System 2 thinking.
Yeah.
And they do that by employing a technique called Monte Carlo Tree Search, or MCTS.
MCTS. Okay. So what's that all about?
It's kind of like think of it like a chess game. The AI explores various solution paths, looking for the best path to win the game, essentially.
That's cool. So it's like it's looking at all the possible moves
Yeah.
and figuring out which one's going to be the best one.
Exactly. But there's a challenge with that. You see, this kind of approach, it needs a lot of good training data.
Ah, yeah. Okay.
And high-quality math reasoning data, that's actually pretty scarce.
So how do they get around that?
Well, that's where the self-evolved deep thinking comes in.
Yeah.
It gets really interesting here. They trained a small language model, SLM, to generate its own training data.
What, using MCTS?
Yeah, that's right.
Oh, wow. So it's like it's teaching itself.
It's kind of like that, yeah.
That's amazing.
And this self-evolution process, it involves three key innovations. First, the AI actually translates its reasoning into code.
Into code.
Yeah, so if the code works, then the reasoning is most likely solid. It helps to eliminate mistakes.
Makes sense, yeah.
Second, they use what's called a process preference model, or PPM.
A PPM.
Yeah, it's like a coach. It gives feedback on each step of the AI's reasoning process.
It's interesting.
And it learns to prefer steps that lead to the correct answer, so it guides the AI towards success.
Oh, so it's like reinforcing the good steps and kind of discouraging the bad steps.
Exactly. And finally, there are 4 rounds of self-evolution. The AI starts with a basic data set, and with each round, it gets progressively better. Like leveling up in a game, it uses that feedback from the PPM to create higher quality data for itself.
Oh, so each round, it's getting better and better at generating its own training data.
Precisely. And that allows it to tackle harder and harder problems.
Wow. So what were the results?
The results were pretty remarkable. They showed that this smaller SLM, even though it's smaller,
Right.
can outperform much larger models on those challenging math benchmarks, like the math benchmark, the American Invitational Mathematics Examination, even college-level problems.
Really? So this small model is beating these big models just because of the way it's learning?
Yeah, it's really quite amazing. And there was another interesting finding, too.
Oh, what's that?
The AI actually showed an ability to self-correct.
Oh, wow. That's fascinating.
It wasn't programmed to do that. It just emerged from this deep thinking process.
I see.
And the study showed that after reaching a certain skill level, the AI's performance was significantly influenced by the PPM. So this emphasizes how important it is to have a good guide or a mentor, even in the learning process for AI.
That's really interesting. So it's almost like, just like humans, if AI has a good teacher or mentor, it can learn better.
That's right. And the PPM, it was really good at identifying those crucial steps where the AI applied theorems.
Theorem application steps, okay.
Yeah, so it shows that the PPM can recognize elegant mathematical arguments, which highlights the importance of understanding those underlying principles, the structure of the subject.
So it's not just about knowing the formulas, it's about understanding the why behind them.
Exactly. And the researchers suggested that this rStar-Math, this methodology, could be applied to other domains too, like code reasoning, maybe common sense reasoning.
Oh, so it could be used to create AI systems that could evolve into experts in all kinds of different fields.
That's the idea, yes.
But wouldn't that be really challenging? I mean, adapting this to other domains?
Oh, yeah, there would be challenges for sure. Like with code reasoning, you would need to make sure the generated code actually works, right?
Right, of course.
And with common sense reasoning, it's difficult because what's considered correct can be very subjective and depend on the context.
Yeah, that makes sense. But what's really interesting to me is, this rStar-Math, it's mainly focused on math word problems.
Yeah,
Right?
right.
But the researchers believe that it could also have potential for theorem proving.
That's a really advanced area of mathematics, even for sophisticated AI.
Yeah, and it requires a really high level of abstract reasoning, right?
Exactly. But they pointed out that rStar-Math, it has actually already demonstrated some theorem-proving capabilities.
Really? So it's already been able to prove some theorems.
Well, it successfully proved an Olympiad-level problem.
Wow.
Using Fermat's little theorem, it provided a step-by-step logical proof, similar to what a human mathematician would do.
That's incredible. So you're saying that with some more development, AI systems could potentially, rival human mathematicians.
It's possible.
Wow.
Yeah.
That could have huge implications for fields like math, computer science, physics. Theorem proving is really fundamental to all those areas. It's amazing to think that we could be on the verge of a new era in mathematics where AI is working together with humans to explore all this incredible mathematical knowledge. It's just mind-blowing.
It really is. I mean, this research, it kind of opens up more questions than it answers.
It does, doesn't it?
It reminds us that we're still really just at the beginning of understanding AI. Its potential, its limitations, it's an incredible journey of discovery.
Absolutely.
Yeah.
So we've covered a lot in this deep dive today, from all the technical details of our rStar-Math to the bigger picture, the implications. It's been really insightful.
Yeah, it has.
What stood out to you the most from our discussion?
I think, for me, what's really striking is that a small AI model can achieve such impressive results if it has the right approach. It shows that size isn't everything.
Yeah.
Sometimes innovative solutions come from unconventional thinking.
Yeah, I agree. And focusing on those fundamental principles, right?
Absolutely.
It reminds me of a key message from this research. Deliberate practice, feedback, being willing to learn from mistakes.
Yeah.
Those are all crucial for success for both AI and humans.
I think that's a great point. It's a powerful reminder that we all have the potential to achieve great things no matter where we start.
It is. It is. And, it's also a testament to human ingenuity.
Yeah.
I mean, we created these amazing AI systems, and they're not only expanding what we can do, they're challenging us to understand ourselves better.
That's a good way to put it. It's a really captivating interplay, this relationship between humans and machines.
It is.
And it's going to shape the future in some profound ways.
Absolutely. It's amazing how this research, it's kind of bridging that gap between artificial intelligence and human cognition.
Yeah, it really is. It's almost like we're seeing our own learning process reflected back to us through AI.
Exactly. And, it makes you think about how this research is challenging, our assumptions about AI and human intelligence.
Right, because we tend to see AI as this, separate thing, right?
Yeah.
Distinct from human intelligence, and it creates this narrative of, competition, AI versus humans.
But this research is kind of showing us that, no, AI can actually be a tool for understanding our own minds, our cognitive processes.
It's not just about building machines that are smarter than us. It's about understanding what intelligence itself really is.
Yeah. And that AI can be like a collaborator in that quest to unravel the secrets of the human mind.
And I think that's a really important perspective to have, especially as we continue to develop these, more and more sophisticated AI systems.
It's like having this new scientific instrument to probe the mysteries of the brain.
And it's an instrument that's constantly evolving too, revealing new insights with each advancement.
One thing that I found really fascinating about this research was the discovery that the AI's performance was really influenced by the quality of that process preference model, the PPM.
Right, and that just highlights how important feedback is. Guidance, mentorship.
In the learning process, for both AI and humans, it seems.
Yeah, it's like having a mentor, someone who can see your weaknesses, help you refine your thinking, guide you toward improvement.
And, the fact that the PPM could pinpoint those theorem application steps in the AI's reasoning, it suggests that a good mentor can also help you see like the elegance of a subject.
Yeah, the beauty, the structure.
It's not just about memorizing facts, it's about developing that deeper understanding, a real appreciation for the subject.
It's about seeing those connections, the patterns, the principles that give meaning to knowledge.
And I think it's also about nurturing that sense of wonder and curiosity that drives us to keep learning.
It's incredible how this research has taken us from, like, the nuts and bolts of AI algorithms
Yeah.
all the way to these profound insights about learning about the human mind.
It's been a really enriching deep dive. It really makes you think about, the importance of staying curious, embracing new ideas, always striving to learn and grow.
Absolutely. And it's a reminder that the pursuit of knowledge, it's a collaborative thing. We benefit from combining human ingenuity with the power of AI.
Yeah, and it's so exciting to think about what we might discover as we continue to explore this uncharted territory together.
I agree. It's a very exciting time.
Well, we've come to the end of our deep dive into star math.
It's been a pleasure discussing this with you.
And to our listeners, we encourage you to keep exploring this topic. Delve deeper into the research. Think about those thought-provoking questions we've raised.
Keep those System 2 thinking gears turning.
Until our next deep dive, keep learning, keep questioning, and keep pushing the boundaries of your understanding.
Farewell.
Farewell.